One of the most challenging things in working with systems of linear equations is actually writing the equations from the verbal constraints. So we have some sentence that tells us or describes something about the variables in question, and then somehow we need to convert that into an equation that will be used in solving the system. So first of all, the key, and this is incredibly important, and a lot of people ignore this. Define variables clearly. That means you should have units on them. So saying things like, let's say you're purchasing tables and chairs for your company to stock in your warehouse, and you just define the variables to be tables and chairs. That's not a measurement. Tables is not a measurement. Number of tables is a measurement, or quantity of tables, as is quantity or number of chairs. So those are the units. You can't just say chairs and tables. You have to specify what are you measuring about them. Are you measuring the table height, the table width, the table length, the table color? There are lots of measurements that you can take on a table, so we have to be clear in specifying the units. Very important. Then, based upon, you want to identify any statements that are going to stand out as things that are going to limit what your variable values can be. So we'll take a look at a few examples, or just as our running example, let's let X be the amount of total annual production for company X. And notice here's my unit. Here is the unit. It's measured in dollars. And again, we can't just say amount of total annual production for company X. Is that the weight of production? How much the total production weighs? Is it how much space it takes up? You can see where we're going with this. The fact that we're talking about the dollars worth of annual production is important here. Y will be the same thing, but for company Y. Okay, let's take a look at a few examples. Let's say we identified a statement that said company X will have twice the production of company Y. Okay, well, that clearly affects the relationship between X and Y. There needs to be a 2-to-1 relationship. Now, before you just say X equals 2Y, I like to, in these situations, create a little t-table and just give myself an example of, okay, we don't know how much they're going to each produce, but we just know that company X will have twice the production of Y. So that in my mind means, hey, if I know the production of Y is 10 units, company X will have twice that, so that will be 20. If company Y has 30 units, well, company X will have twice that, which would be 60. And so, indeed, in this case, X is equal to 2Y is the equation that quantifies this sentence. Now, keep in mind that the order in which the variables appear is not the way you should write X will have twice X equals 2Y, because I can actually rephrase that in a way where it'll make it seem like it should be Y equals 2X. I could say whatever company Y produces, X will produce double that. And in that case, it almost seems like it should be Y equals 2X. So if you get stuck, whether it's X equals 2Y or Y equals 2X, or just better yet, create a little t-chart, give yourself a couple of examples, and then immediately, numerically, the relationships should stand out. Because now if I plug in 10 for Y into my equation, 2 times 10 is 20, which is what I get for X. And so our equation should actually mesh with what is in our table. If it's not producing the ordered pairs in our table, then we know we've made a mistake, because the table was our practical interpretation of it. So sometimes we get a little bit stuck whenever we're working with variables coming from words. Company Y will have 30% less production than X. Okay, what does that mean? Well, that means that whatever X produces, Y will have 30% less. Okay, well, let's think about that. Let's say that company X has a total production of 100 units. So 30% less than that. Well, first of all, I would want to figure out what is 30% of 100. Well, that's 30. So company Y should have 30 less than 100, which would be 100 minus 30, which is equal to 70. If this were 200, well, again, we need to take 30% of 200, which is 60, and so y would produce 30% less, which would be 60 units less, which is 140. So the quantity that's changing here is this subtraction term. How did we figure that out? Well, to get some value of whatever x is, y has to be that value, which is x, minus 30% of x. And, well, we can simplify that a little bit. If you notice that this is 1x minus 0.3x, this is 0.7 of x. So another way of saying 30% less production would be saying 70% of the production of x. Okay, that just makes a little bit more sense, because rather than having to subtract off, we could just think about, well, if it's 30% less, then it's 70% of. If it's 60% less, then it's 40% of. And so in this case, we know that y is going to equal 0.7 of x. And that's usually the way we want to write it. All right, let's take a look at another one. Company X will produce $500 more than company Y. Now, I just want to point out that in all of these examples so far, both of these examples so far, notice that the reason we knew that these sentences were going to have to be converted into equations is because they placed limitations on what x and or y could take on. Now, they don't tell you exactly what value they should be, right? Because in example 1, we just looked at two ordered pairs. We could kind of keep on going. Y was 100, the next would be 200. And there are infinitely many possible pairs that satisfy that, but this statement limits the relationship between x and y. So it doesn't necessarily tell you what x is or what y is, but it dictates how those two variables should be related. Similarly, in example 2, this statement created a relationship between x and y is 0.7 of x. Example 3, company X will produce $500 more than company Y. Absolutely, that's another statement that suggests that. So again, I'm going to create a little t-chart here just to make sure I don't make any mistakes. It takes just a minute to do. Okay, so X will produce more than company Y. So if Y was to produce $100 worth, company X will produce 500 more than that, which would be 600. They produced 900, then 500 more than that would be 1400. So this tells us that X is going to equal Y plus 500. Another way of doing this, and you can actually see it algebraically, you could subtract 500 over. Y will produce whatever X produces, but $500 less than that. Right? So if X produces 500 more, then Y produces 500 less. And these are both totally valid statements. They're equivalent equations. X needs to produce $800,000 in total over the next 10 years. Now, it doesn't really make a whole lot of sense to try to construct a table here because the annual production X would need to be an amount so that if you multiplied that number by 10, you got 800,000, right? Little x is the total annual production. So if I produce X, and this is in dollars per year, that's the units of X. It's going to be the annual amount of money produced. And I multiply that by 10, that's the number of years. If I multiply years by, or years over 1 if you prefer, then you're going to get the total dollars that you produce. And we know that that should equal 800,000. So there's our equation, 10x equals 800,000. You can actually solve for x pretty quickly here because, hey, this tells you exactly how x should be calculated. It should be 1/10 of 800,000, and 1/10 of that would be 80,000. So that's the total annual production under that constraint. You can't do that in examples 1 through 3 with only one constraint because, again, as we saw in our tables, there are infinitely many pairs. The equation just expressly limits the relationship between those pairs, meaning in example 1, one had to be double the other. Okay, two more examples. Building upon this notion of how do we take information and convert it into equations. The two companies will be taxed at 15% of their production each year. The combined total taxation was $20,000 this year. All right, interesting. Okay, so that means that if I take 15% of X, that's 15% of their production. So if I take 15% of X, this is the on company X, and 0.15 of Y will be the total tax on company Y. Now, when I combine those, when the combined total, I total the taxes, that should come out to $200,000. So 15% of dollars is dollars. 15% of dollars is dollars. Dollars plus dollars is dollars. So notice that my units are still dollars plus dollars equals dollars. That's another key point that I want to emphasize here is always check your units. The easiest way to make a mistake is, let's say you end up with dollars equals units. That doesn't make sense. You can't have dollars equals units, just like you can't compare 10 bananas to 10 apples because you have different pieces of fruit, different quantities that you're same quantities of different items. Another way you could do this is you can just say, hey, whatever X, since they're being taxed at the same rate, add up their total production, and whatever their total production is, take 15% of that for taxes, and that total should be 200,000. Notice how when I say this, it kind of flows nicely. I can actually convert my language into a mathematical equation, and that's with a little bit of experience, you kind of get to that point where you can talk out the equation. And I just want to emphasize, algebraically, you could distribute the 0.15 and you get exactly the first equation we got here. Okay, so sometimes we have to get pretty creative with how we think about things, but we have to think about the context. So company Y wants to ensure equilibrium production. This means that they want the total production, which they will sell. So assuming that what they produce, they're going to sell, right? So they take these X units, they're going to sell. They're going to sell whatever dollars worth of production they create. They want their total production to be the same as their total expenditures. They will. So okay. So they want their, and I'm going to write this. I'm going to say production equals expenditures. Okay, that's key here. In this situation, this sentence tells me what it means to ensure equilibrium pricing. I want the production in dollars to equal the expenditures in dollars. Okay, so get dollars equals dollars. Well, to write this out, let's think about how much company Y produces. Well, oh, I'm sorry, this should have been Y here. Company Y produces Y dollars worth of product. So that's their total production. So the left-hand side of this equation is their total production amount, Y dollars. I want that to equal how much they spend. Well, what are they going to spend money on? They're going to purchase 7% of company Y's production. Okay, so that's part of their expenditures, 7% sorry, this should read company X. So they're going to purchase 7% of company X's expenditures. Okay, and so if company X produces $100 worth of product, they're going to buy $7 worth of it. And they will consume 3% of its own production. Okay, so sometimes when we think about a company that creates something, there's probably waste in the form of, if you're making postcards, you're probably not going to end up using the whole sheet of paper, and you're going to have a little bit of waste, and so you waste some of the product that you created. So they're also going to have to, that's part of their expenditures. So in addition to the 7% of company X's production they'll buy, they are also going to purchase 3% of their own. Okay, so production equals expenditures. And notice that in this situation, there's the variable y appears both on the left and the right, and that there's nothing wrong with that. In fact, if you were just to subtract this 0.03y over, and I find that sometimes this makes a little more sense, is that you have 1y minus 0.03y. 1 minus 0.03 is 0.97y, and you get equals 0.07x. And the practical benefit of this is that now you're saying that your total production is actually 97% of what you produce, i.e. 3% is not part of what you're going to be able to sell because you're using that up, your weight in form of waste. And then your expenditures, you're buying 7% of X's production, and therefore that's your total expenditure. So these are just a few examples of one context, but notice that in each situation we have to go back to the units, and this is why things like annual production and measured in dollars are incredibly valuable when we're trying to do computations that lead to constructing equations. So just lots of practice, we get much better at this.